Welcome back. In the previous video, I explained to you about logic and system specifications. We looked into the ways that systems are built logically and how basically you can verify, or you have to verify, that all the specifications that you put in the system are in fact consistent. In this new video, I will look at Boolean searches and their application. Boolean logic is very interesting. It can be used in many applications. And for example, when you're doing a search on the internet, in Google, for example, you're basically applying Boolean searches. Here we are going to define what those Boolean searches are, what are the principles, and in the follow-up sessions, we will look more into different operators and creating Boolean searches. Now let's have a look. First of all, we have to define what Boolean searches are. Basically, Boolean searches are built on a symbolic logic that was already developed in the 19th century by an Englishman named George Boole. That's why we call it Boolean logic. They are techniques, or they use in fact techniques that come from propositional logic, and you will see that we can use the Boolean terminology together with propositional logic, and we can create from a Boolean development, from a Boolean schedule circuit, we can define how the propositional logic of it looks like. Now, the Boolean searches are basically using words to combine phrases, words and phrases, and they are using the words and, or, and not. So there are different ways to use that logic, and we will look into some examples. When we look and, or, and not logic, first of all, the and logic means that we are considering A and B, and we have here a Venn diagram where we have elements related to, let's say, a group of data. We call it A. We have a group of data B, which are in the second Venn diagram, in the blue Venn diagram. When we say there are certain properties that A and B have, it means A and B, and it's the colored intersection of A and B. So here we have properties A and B should be compliant. Another element is or, and when we look at it, it's A or B. So basically, when we combine those two, we look at adding A and B. We put everything together in one colored Venn diagram. Now here you already see that and corresponds with the and function we used in propositional logic, and or also corresponds with the or function that we used in the propositional logic. There is a third one that we can define. We call it not A. So we exclude everything that it's not related to A, and we have only the elements that have, for example, properties that are unique to B. They're not unique to the others, only unique to B. So these are the three logical statements, and, or, and not, but we will see in the next video that we are going to use them, and we are going to create additional logical statements. Let's have a look at an example of Boolean logic. We have two statements here. We look at people having a master's degree and people having a bachelor's degree. Now here we look at people who are having an MBA. I put an MBA here as a master's degree, and a BBA. So basically those are the people who are in possession of both of the degrees. People may have only a BBA degree, There may be some people who only have an MBA degree. They could have another bachelor or another master's degree, but not a BBA. And the intersection are the people who have both degrees, an MBA and a BBA. Now we look at the OR function, the OR logic. Well, an MBA or a BBA, it means all of them. So all the people are considered in these OR functions. And then we look at the people who are not having an MBA, but people who have only a BBA. So all the people who have a BBA, but also an MBA, are excluded. So that's the logic, not an MBA. When we look at internet searches, we can use the Boolean logic. And when we look at Facebook or LinkedIn or other applications, we are in fact looking at certain elements. And you may be looking in LinkedIn, for example, people whose function is project manager. You may try to find people who are CAPM certified, CAPM or PMP certified, both certifications issued by the Project Management Institute. CAPM is a Certified Associate in Project Management, and the PMP is the Project Management Professional. And then we want to include eventually people who are located in Prague. Now let's look at some elements when we look at some possibilities, how to use Boolean logic to conduct searches. The first example I want to consider is, in fact, we have a project manager and they are in Prague and they have a CAPM. So here we have three elements that are very important here. Project manager, Prague, and CAPM. So basically all three conditions have to be true. Now this search will give you the list of all the project managers in Prague, but also having a CAPM certification. Now these are elements that we can add. We can put those selection terms in there, and when we use it in Facebook or in LinkedIn, how we put those elements together will lead to different search results. Another example is I want to have project managers and PMP, but they are not in Prague. Now we want to find out project managers with a PMP certification who are not in Prague. And we find all those people, project managers, but project managers in our case means in the function of project manager. We may have PMP people who are not in the function of project manager or have a different function title, and they will not be selected. So we need project management and PMP, but they should not be located in Prague. So those are examples of Boolean logic. We will use it later. In the next session, we will talk about some other applications. So this was the end of this session. We look at the different elements and we looked at the Boolean logic, but in the next part we will be looking deeper into logic puzzles. You're doing a great job. Keep up the work, keep on reviewing and studying, and soon we will have finished the course. I'm looking forward to seeing you in the next presentation. Thank you and bye-bye.